Hello, good morning students. As we have started yesterday, the lecture 1, that is some P block elements, right? I have given you just introduction to the P block elements, okay? And in the previous class, I have given you regarding physical properties of 15 group elements, okay? As I told you, these 15 group elements are called as nicogens. That means they exist as gases mainly, as a suffocating gases, right? And these 15 group elements already I told you they include nitrogen, phosphorus, arsenic, antimony and bismuth. And I told you yesterday in the previous class, the general electronic configuration of these 15 group elements, particularly 15 group elements is what? NS2, NP3, right? Then I told you regarding atomic radius. That means size is expressed in terms of atomic radius. The atomic radii of these 15 group elements down the group generally increases as size increases. But across the period, when we compare the 14 group element, these are having smaller atomic radii due to effective nuclear charge. Okay, and when we compare this nitrogen, phosphorus, arsenic, antimony and bismuth regarding next ionization energy. Generally, ionization energy and atomic size they are inversely proportional. If size increases, ionization energy decreases down the group. But these are having abnormally high ionization energy due to half-filled orbitals. As you know from our first year knowledge, half-filled orbitals they gain extra stability. Okay, NP3, see 3 unpaired electrons. They gain extra stability due to what? Exchange energy. Okay. Then that means ionization energy of these 15 group elements is generally more than the 14 group elements because atomic radius decreases. Right. Now coming to the fact next regarding I told you yesterday itself, electronic configuration, atomic radius, ionization energy, right students? Then electronegativity. Across the period generally you know that electronegativity increases but down the group decreases. So from nitrogen to phosphorus to arsenic to antimony to bismuth, electronegativity down the group decreases. Why? Because non-metallic character decreases, metallic character increases. I will repeat, that is as you already know, nitrogen, phosphorus, arsenic, antimony and bismuth. Right? Nitrogen is non-metal. Remember. Phosphorus is also non-metal. Okay? Arsenic metalloid. Arsenic is metalloid. Antimony is also metalloid. Antimony is also metalloid. Bismuth is predominantly metal. That's why electronegativity, you know that non-metals are more electronegative and also size, smaller size. The most electronegative is nitrogen. Next phosphorus, metalloid, residue character of both metals and non-metal, therefore electronegativity character decreases down the group. Right? That means electronegativity decreases down the group. Okay, that's why non-metallic character decreases down the group. Okay, the next metallic character increases. Metallic character increases down the group. Remember. Okay, so electronegativity decreases but non-metallic character decreases but metallic character decreases and the metallic character increases. Basic character also increases. Right? Please remember non-metals are acidic in nature, metalloids are amphoteric in nature whereas metals are basic in the nature. This point is to be noted. So this is how yesterday's class I stopped here. Okay, now in continuation of the atomic radius, right? That is ionization energy, electronegativity, now is non-metallic character and metallic character. Let us go to another more physical properties like their physical states. I told you yesterday itself. Now lastly remaining melting point and boiling point. Okay. Then whether they exhibit the allotropic property or not. That we will discuss and we will go further. Right, students. See here. After this electronegativity character, now let us move on to suppose again points N2 exists as diatomic gas, whereas other elements, okay, exist as tetraatomic points. Like for example, P4, okay, then AS4, SbF4, and Br4, like that. Then regarding next melting point and boiling point. So as far melting point and boiling point is concerned, melting point and boiling point from nitrogen, remember from nitrogen to phosphorus to arsenic to antimony to bismuth. Okay, from nitrogen to arsenic generally melting point and boiling point increases. Melting point and boiling point increases. Okay, it increases. But from arsenic to antimony it decreases. From arsenic to antimony it decreases. Why? See, melting point and boiling point from nitrogen to phosphorus to arsenic increases due to increase in the atomic size and increase in intermolecular forces. But when you come to antimony to bismuth, this is not true. Why? Because due to one of the important effect called as from arsenic to antimony to bismuth only decreases. Why? Due to inert pair effect. Okay? Due to inert pair effect. I will tell you further what is this inert pair effect. Exactly in oxidation state. Okay, there I will tell you. Due to inert pair effect, melting point and boiling point decreases from arsenic to bismuth, but increases from nitrogen to phosphorus. And right here, from nitrogen to phosphorus, that is arsenic, MP and BP, okay, increases. From arsenic to bismuth, melting point and boiling point decreases. Due to what? Due to inert pair effect. Due to inert pair effect. Remember, I will tell you later what is this inert pair effect. So this is regarding melting point and boiling point. Now nextly regarding allotropic. Okay. Allotropic. Okay. All elements except nitrogen and bismuth exhibit allotropy. So what is this allotropy, students? Allotropy means it is the different form of a same substance, different form of a same substance existing in equilibrium with each other, at a definite transition temperature. Those are called allotropes. In the last year in the PUC group elements, I studied allotropes of the carbon, that is carbon diamond, carbon graphite and fullerenes. Like that. Diamond can be converted to graphite, graphite can be interconverted into diamond, but at definite transition temperature. Okay, that's what allotrope. That means nitrogen never exhibit allotropic property, even bismuth also. Why? Because nitrogen cannot extend its covalency more than 4, and bismuth due to inert pair effect. +3 oxidation state become here stable. Here also plus 3 state oxidation become stable. That's why there is not exhibit allotropic property, right? But other elements means phosphorus, arsenic and antimony, okay, they exhibit allotropic property. What are the allotropes of the phosphorus? Phosphorus exhibits mainly 3 types of allotropic properties. What are those? White phosphorus, red phosphorus and black phosphorus. Even in some books they are given scarlet and violet. Okay, 5 types of allotropic properties. But basically we are having what? White phosphorus, red phosphorus and black phosphorus. Alpha black and beta black phosphorus. Okay. Like that, arsenic and antimony, they are having yellow and grey crystalline forms of the allotropes. But purely they are in crystalline form, not in the amorphous state. Remember, right? This is about allotropic property. Okay, and especially remember in the CET and for NEET purpose, this is important. Only for arsenic to bismuth melting point increases. Why? Due to inert layer effect. Means formation of trivalent triple bond becomes more stable for this what antimony to bismuth. That's why. Remember. Okay. Right. So that's about physical properties. Right. That means purely physical properties. Yesterday what I given you, electronic configuration, then atomic radius, then now ionization enthalpy over. Once again I given you electronegativity. In electronegativity only metallic character, non-metallic character, okay, acidic character, basic character, and now melting point and boiling point. Once again physical existence and allotropic properties. Okay, right. Now this is the completion of physical properties. Now let us move on to very importantly chemical properties. Chemical properties of these 15 group elements. Okay, physical properties over. Now it's a turn of chemical properties. Chemical properties of 15 group elements. Okay. In chemical properties, the first point is regarding oxidation state. Regarding what? Oxidation state. Students, you already know in the first year what is oxidation number and what is this oxidation state. This oxidation number or oxidation state is nothing but it is the apparent charge carried by an atom or ion or a molecule or polyatomic ion or a complex ion. It may be positive or negative or even zero. Even it may be fractional also. That you already know from your redox reaction knowledge. Right? Okay, now these 15 group elements, nitrogen, phosphorus, arsenic, antimony, bismuth, all these elements, 15 group elements, okay, that is 15 group elements, generally exhibit -3, +3 and +5 oxidation state. Variable oxidation states. They exhibit -3, +3 and +5 oxidation state. Let us see how. See nitrogen, okay, -3 to +5. It varies from -3 to +5. What are those? Let us give the example. See NH3, ammonia, okay, then NH2, hydrazine, where here an oxidation state is -3, that is -2, then hydroxylamine, -1, okay, then nitrogen elemental state 0, nitrous oxide +1, nitric oxide +2, dinitrogen trioxide +3, dinitrogen tetroxide +4, dinitrogen pentoxide +1. Like this, nitrogen exhibits variable oxidation state -3 to +5. This you studied in already first year. -3 to +5. These are the compounds. Please remember, students, DV are very important for C2. Okay. In ammonia it is -3, in hydrazine it is -2, hydroxylamine -1, elemental nitrogen according to oxidation number rule 0, nitrous oxide laughing gas +1, nitric oxide +2, dinitrogen trioxide +3, dinitrogen tetroxide +4, dinitrogen pentoxide +5. Okay, this is the nitrogen. Like this, then phosphorus. Phosphorus also -3 to +5. Okay, but very not like this really. It is having phosphine PS3 -3. Okay, then like this only P2H4 -2. PS2 or P2H4, this is called diphosphane vapors. Then after phosphine, it is a time of PS2OH -1. Like this here also it exists as P4 in elemental state 0. But in oxide form, okay, P2O3, P2O5 or halide, PCl3, PCl5, +3 and +1. Phosphine -3, diphosphane vapors P2H4 that is -2. Okay, PS2OH, how we call hydroxylamine, it is also hydroxyl group of the phosphine group. Okay, then P4 state. See how nitrogen exists as diatomic. This is tetraatomic, as I told you in the physical properties. Other elements they exist as tetraatomic solids. Okay, P4 0, P2O3 +3, P2O5 +5. Okay, even you can also write them as P4O6 and this is as P4O10. Right? Okay. That means trioxide, phosphorus trioxide, phosphorus pentoxide. Remember. Then other elements that is usually nitrogen, phosphorus, arsenic, antimony, and bismuth. See here, arsenic as As2O3 +3 1, As2O5 +1. Antimony also same thing, Sp2O3 and Sp2O5. Even bismuth, Bi2O3 and this is Bi2O5. Okay, this is in detail. The first physical property that is called oxidation. That means generally these elements exhibit the oxidation state from what? -3 to +3 to +5. Okay, right. Now another important point to be noted. That means down the group, if you go from nitrogen to bismuth, +3 oxidation state becomes stable. +3 oxidation state becomes stable. Hence, As2O3, Sp2O3, Bi2O3, right? Even there N2O3, right? They have become stable. Bi2O3 is more stable than Sp2O3, Sp2O3 is more stable than As2O3. But for nitrogen and phosphorus, in +5 oxidation state becomes stable. For nitrogen and phosphorus, +5 oxidation state becomes stable. Why? Because they do not exhibit one of the important properties just now I told you, inert pair effect. For nitrogen and phosphorus, please point to be noted, students. +5 oxidation state becomes stable. But for arsenic, antimony and bismuth, +3 oxidation state becomes stable. Why? Due to inert pair effect. Due to inert pair effect. And most inert pair effect is exhibited by bismuth. That means down the group oxidation number decreases from +5 to +3. +3 becomes stable down the group. And if you go reverse from bottom to top, +5 oxidation state becomes stable. Remember. Why? Due to inert pair effect. Inert pair effect. And this is very, very important. Very, very important for 2 marks for theory. Please remember, students. Very important for 2 marks for theory. See, I will write here point to be noted. Due to, okay, inert pair effect. Inert pair effect. Okay, +5 becomes stable. +5 becomes stable for what? Nitrogen and phosphorus. Next, due to inert pair effect. Inert pair effect. Okay, +3 becomes stable. Stable for what? Stable for arsenic, antimony and bismuth. Okay? Right. Why? Due to inert pair. This is very important for need purpose. Right. Now, afterwards, another point are to be noted for this is now definition of inert pair. If they ask you, explain the oxidation state exhibited by 15 group element. Compulsory to write. First, they exhibit generally -3 to +3 to +1. Okay, then you have to not necessary to write all these examples. This is the extra information I am giving you for your need purpose and CET purpose. Okay, and even JEE main subject. Right. Now, coming to the fact that what is inert pair effect. After writing that, you have to write. This is important. +5 for nitrogen and phosphorus and +3 for arsenic, antimony, bismuth. These points have to write for 3. Then you have to write definition. We did ask for 2 marks. What is the definition of inert pair effect? What is inert pair effect? Remember, what is inert pair effect? It is defined as the reluctance of Np electrons. The reluctance of Np electrons in chemical bond formation. Chemical bond formation compared to Ns electron. Compared to Ns electrons as Ns, the reluctance of Np the reluctance of Ns electrons compared to Np electrons as Ns electrons are diffused into the nucleus. Is called inert pair effect. Okay, inert pair effect. And repeat, the reluctance of Ns electron means S electrons compared to P electrons in chemical bond formation. Why? Because Ns electrons are highly diffused into nucleus compared to Np electron. That increases effective nuclear charge and becomes stable. Okay, that means when you observe, assume that this is central nucleus. In atomic structure you study, this is S electron, P, D and F electrons. Which are more near to the nucleus? S electron. Therefore, they are highly diffused compared to N. This means these are involved in chemical bond formation, but these are less important. They do not show reluctance, means negligence. Do not show any what we call it as response towards or interest towards chemical bond formation. Why? Because they are having nuclear force of attraction on them more. That's why it is called highly diffused into nucleus. Because of that, they become more stable. +3 state becomes stable. That is called inert pair effect. Please, students, try to remember this definition. What is inert pair effect? The reluctance of Ns electrons in chemical bond formation. Okay, compared to Np electrons, as Ns electrons are highly diffused into nucleus. That means general electronic configuration of this 15 group elements you know, Ns2, Np, right? That means only Np 3 electrons they can use. Therefore, +3 oxidation state becomes stable, but not Ns. See, oxidation state is explained on the basis of both this valence electron. If they lose P, +3. If they lose both S and P, +1. That's why if they do not lose this, only +3. Okay? Why? Because they are highly diffused into nucleus. Remember, once again. again I will repeat. What is inert pair effect, students? Inert pair effect is the reluctance or negligence or disinterest of Ns electrons in chemical bond formation compared to Np electrons, as Ns electrons are highly diffused into nucleus. Is called inert pair effect. Due to this inert pair effect, down the group +3 state becomes stable for 15 group elements and +5 becomes unstable. That means nitrogen and phosphorus are stable with +5 oxidation state, whereas arsenic, antimony and bismuth, they are stable with the +3 oxidation state. Point to be noted and very important for CET and NEET, and also for theory purpose you will ask this for definition 1 marks and even oxidation state variation for 2 marks. This is one chemical property of 15 group elements. Okay, I think you understood this concept and please try to remember this. Okay. After this inert, that means oxidation state, as I told in the beginning only, melting point of bismuth is less than all other elements. Why? Due to this only inert pair effect. Okay, right. Okay. Now coming to next chemical properties after oxidation state, it's a reactivity. Reactivity with the hydrogen. This is important. Reactivity with the hydrogen. How these 15 group elements react with the hydrogen? Simple. See, especially these 15 group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. Once again, nitrogen, phosphorus, arsenic, antimony, and bismuth. They react with the hydrogen and form respective hydrides. They form hydrides with -3 oxidation state. What are those? Let us see. The hydride formed by the nitrogen is ammonia, NH3. Okay, hydride formed by the phosphorus is phosphine, PH3. That means phosphine or phosphine. Then it is called ASH3, arsine. Okay, arsine, right? Then stevine, SbH3, stevine. Then bismuthine, BiH3, bismuthine. Okay, that means the 15 group elements react with the hydrogen and forms respective hydrides, okay, of the type EH3. That's why ammonia, phosphine, arsine, okay, that is arsine, right? Then stevine, bismuth. Remember, NH3, BH3, ASH3, SbH3 and DiH3. And here oxidation state of the central metal atom, nitrogen, phosphorus, arsenic, antimony, bismuth, they are what? -3. In hydride, you know that hydrogen is always in the what? -1 oxidation state. In hydrogen, normally H++1. In hydride, it is -1. Okay, that's why central metal atom is -3 here. -3 oxidation state. Remember. Okay, right. Now, this is regarding reactivity. Next, what are the properties of these hydrides? Hydride formed by the, right, this nitrogen, phosphine, arsine, stevine, bismuth. Okay, now I will tell you regarding their important point to be noted for CET. First one, regarding stability. Okay, regarding the stability. First one, stability of hydrides. Stability of hydrides. Stability of hydrides of 15 group elements. 15 group elements. Okay. Decreases down the group. nitrogen to bismuth due to decrease in bond dissociation energy. Remember, bond dissociation energy. That means if you go down the group, you know that central metal atom nitrogen 7, phosphorus 15, 15 plus 18 33, 33 plus 18 51, 51 plus 32 82. Down the group atomic size increases, therefore bond dissociation energy, the energy required to break the bond decreases, therefore stability decreases. That means stability of the 15 group element decreases from top to bottom, that is from nitrogen to bismuth. Why? Due to increase in atomic size and decrease in the bond dissociation energy. Decrease in the bond dissociation energy. That's why second point to be noted for need purpose. Very important for need. Okay. What is that? Reducing property. Reducing property of hydrides. Reducing property of hydrides increases from nitrogen to bismuth. That means, see, nitrogen to bismuth, the reducing property of hydrides increases. Why? Because ability to donate hydrogen becomes easy. Why? Because bond dissociation energy decreases. As it loses the hydrogen easily, reducing property of hydrides increases. Okay. That means if you break the bond easily, hydrogen can be released, acidic property increases. As a result, what will happen from nitrogen to bismuth? The hydrogen accepting tendency increases. That's why reducing property increases from nitrogen to bismuth. Therefore, bismuth is the strongest reducing agent compared to others. So, remember students here, the stability or reducing property follows this. Okay, that is PiS3 is more reducing than, after bismuth, that is antimony SpS3, right? Then arsine AsS3, then phosphine PS3, then ammonia. Ammonia is the weakest reducing agent and bismuthine is the strongest reducing agent. Remember. Okay? Then this is regarding what? Reducing property. Then coming to next, very important thing. Acidic strength of hydrides. Acidic strength of hydrides of 15th group. Increases from nitrogen to bismuth. Why? Because bond dissociation decreases, ability to lose the hydrogen, give the proton becomes easy. That's why acidic strength increases. That means ammonia is less acidic than phosphine. Phosphine is less acidic than that is nitrogen phosphorus arsenic AsS3Rc, stibine SpS3, then bismuth. This is the increasing acidic character. Which is more acidic? Bismuthine is more acidic. Okay? Correct. But ammonia is less. Then basic character exactly opposite of this. Basic strength or basic character decreases from nitrogen to bismuth. That means NH3 is more basic than phosphine. Phosphine is more basic than arsine. Arsine is more basic than stibine. Stibine is more basic than bismuthine. Least basic bismuthine, most basic ammonia. Means here is explained on basis of donation of electrons. That means the electron donating capacity of ammonia is more because it's having lone pair of electrons on nitrogen, phosphorus, arsenic, antimony, bismuth. This electron donating tendency decreases Okay, this is called Lewis base character. Lewis base character is more for ammonia and very weakest for bismuth. An exact is opposite C. Less acidic, more basic. Very easy to remember. Want to be noted for very important for need purpose. Very important for need purpose. Right? Once again, I will repeat. See, stability of hydrides decreases down the group due to decrease in the bond dissociation energy. Due to decrease in the bond dissociation energy, availability and the release of proton become easy. That's why, see here, acidic character increases from ammonia to bismuthine. Okay, and even reducing property also. Reducing property decreases from nitrogen to bismuthine. Therefore, bismuthine is the strongest reducing agent, and this is ammonia the weakest reducing agent. This is from descending order, highest to lowest. Even in reverse order also you can write this for CET purpose. Here I have according to this word, NH3 is less than TS3, TS3 is less than ESS3, ESS3 is less than ammonia. But strongest reducing agent is this one. That printer I have done here. Okay? Once again, for not confusion, or you can also write this as what? NH3, right? ES3, right? ESS3, right? SBS3, right? Then this is from lowest to highest, ascending order, and this is descending. Right? So that's about the other properties, characteristics of the hydrides. Remember, these 52 elements react with hydrogen and form respective hydrides. Okay, that is of the type ES3. That's only the hydride formed by the nitrogen ammonia. Phosphorus 6-phosphate, arsenic is arsine, and antimony is stibine, and bismuth is remember this. Okay? Very important for even 2 marks and very important for need purpose. Because generally you will confuse regarding acidic character, basic character, reducing property. Remember, acidic character increases if the release of proton, hydrogen becomes easy. If it is easy, remember, it is related to reducing property. Reducing property increases. Easy. Reverse of that is the basic character. That's why ammonia more basic, bismuthine less basic. Bismuthine more acidic, ammonia less acidic. Remember, that's why I give you one to remember this easy. Okay? So that's about hydride. Hydride form. But remember here, oxidation state of central atom will be -3. In hydrides always oxidation state is negative. That's about reactivity with the hydride. Okay. Then coming to next, regarding students, reactivity with oxygen. Okay, reactivity with the oxygen. Here are the same thing. 15 group elements. 15 group elements react with oxygen. Form oxides of the type N2O3 and N2O2. Means they form respective trioxides and pentoxides. Okay, let us see. First, nitrogen forms N2O3, N2O5. But phosphorus P2O3, P2O5. Arsenic AS2O3, AS2O5. Okay, antimony Sb2O3, Sb2O5. Okay, and bismuth But remember, this N2O5 is highly unstable. Because generally nitrogen can form only plus 3 oxide state, plus 5 does not exhibit inert pair effect, but still they are stable, exist in the solid state. Okay. Once again I will repeat, see 15 group elements react with the oxygen and respectively from trioxides and pentoxides. Trioxides and pentoxide of this type. But remember, nitrogen and phosphorus down the road nitrogen and phosphorus both are non-metals, right? Non-metal. Okay. Arsenic, antimony, I already told you, these are metalloid and metalloid. And bismuth, this is a metal. Okay. So here, oxides of the nitrogen, they are acidic. They form acidic oxide. Phosphorus also acidic. Acidic oxides. And both these two, they form amphoteric oxides. Amphoteric oxides. And metal form basic oxides. That means down the group, what is happening? Acidic character of oxides decreases from nitrogen to bismuth. Okay. And remember, here plus 3 oxidation state, central metal atom here plus 1. Here plus 3, here plus 1. Here plus 3, here plus 1. Here plus 3, and here plus 1. And here plus 3, and here plus 1. That means, why I am telling this fact means as the oxidation number increases, acidic character of oxide increases. That means N2O5 is more acidic than N2O3. P2O5 is more acidic than P2O3. AS2O5 is more acidic than AS2O3. Please point to be remembered, very important for comparison for acidic properties in CET and NEET purpose. Point to be noted, students. As the oxidation number increases, acidic character, not only oxides, even halides also increases. Remember. Okay. Next, see here. Down the road, in general, I told you the acidic character increases. But which is more acidic here? Nitrogen is more acidic. Why? Because smallest size, highest electronegative atom. But when we compare between the same themselves, if the oxidation number increases, acidic character increases. Okay? Right. So that's about reactivity with the oxygen by the 15 group elements. Okay? That is 15 group elements react with oxygen and form the respective oxides, that is trioxides and pentoxides. But generally, pentoxides are more acidic than trioxides. In general, from top to bottom, acidic character decreases. Nitrogen is the most acidic, and that is bismuth is the least acidic. Okay, that means bismuth is more basic in the nature. Like chlorotoluene's basic oxide. Metalloids form amphoteric oxides. Amphoteric means that you know they exhibit good character of acidic as well as basic. Non-metal always acidic oxide. Okay, right. That's about reactivity with the oxygen in detail. Now coming to last is reactivity with the halogens. Last chemical property. Reactivity with the halogens. How is reactivity with the halogens? Reactivity with halogens. Okay, see. Nitrogen, phosphorus, arsenic, antimony, bismuth. Once again, 15 group elements. Remember, 15 group elements reacts halogens to form halides of the type EX3 and EX4. EX3 and EX1. So nitrogen will form NCl3 but does not form pentahalide. It does not form pentahalide. Why? Because absence of d orbitals and covalence is only 4. It cannot extend more than 4. Very point to be noted for 1 marks. Very rare, very frequently asked question and for NEET also. It may not form pentahalides. Why? Absence of d orbitals. Next, phosphorus. PCl3, PCl5 can extend covalency more than 5. Okay. Then this arsenic trichloride, arsenic pentachloride. Even SbCl3, SbCl5. Okay, BiCl3, BiCl5. That means except nitrogen, phosphorus, arsenic, antimony, bismuth, they form trihalides as well as pentahalides. Pentahalides can be fluorine, chlorine, bromine, iodine. But most stable one is fluorine. Okay. As the size of the central atom decreases, definitely stability also decreases. But remember, here also point to be noted, trihalides here +3, +3, +3, +3. Pentahalides +5, +5, +5, +5. Already I told you. Here also, as the oxidation number increases, no doubt acidic character increases, even covalent character also increases. Please point to be noted. As the oxidation number increases, covalent character also increases. That means pentahalides are more covalent than trihalides. Remember, pentahalides are more covalent than trihalides. Why? Because as the oxidation number increases, covalent character increases. Okay? And here also once again, which are more stable except nitrogen, all other elements, trihalides or pentahalides, they are more stable except nitrogen. But once again, for seeing purpose, in nitrogen exceptional cases, NF3 is only stable, but all other halides, they are unstable for nitrogen. Okay, and pentahalides are more covalent than trihalides exclusively. Remember, except once again, except that is BiF3, all are more covalent. They are covalent trihalides. Remember, like this, you can explain regarding the reactivity with the halides. Remember. Here one more point to be noted. I told you 2 points. While reactivity with the oxygen, as oxidation number increases, acidic character increases. Like this here also, as oxidation number increases, covalent character increases. Point to be noted. Always lower oxidation state element they form ionic compounds. Higher oxidation state element they form covalent compounds. Very important point to be noted for CET and NEET. Okay. So that's about reactivity with the hydrogen, reactivity with the oxygen, and reactivity with the halogens. Complete. See, these 15 group elements react with hydrogen and form the respective hydrides. Stability of hydride decreases down the group due to decreasing bond dissociation energy. Okay, acidic character increases, basic character decreases, reducing power increases. But they react with oxygen to form the respective oxides of the type trioxides, pentoxides. Pentoxides are more acidic than trioxides because as oxidation number increases, acidic character increases. Okay. Nitrogen, phosphorus, they are non-metal, they form acidic oxides. And arsenic, antimony, they are metalloid, they form amphoteric oxides. And bismuth, metal, they form basic oxide. Down the group, acidic character decreases, basic character increases. And they react with the halogen and form the respective halides of the type trihalides and pentahalides. Pentahalides are more covalent than trihalides because oxidation number increases. As oxidation number increases, covalent character increases. That's it. That's about reactivity with the hydrogen, that is oxygen and halogen. This is the completion of what 3 important chemical properties of the 15 group elements. Then coming to reactivity with the metals. Lastly, reactivity with metal. See this 15 group element, nitrogen, phosphorus, arsenic, antimony, bismuth. They react with metals also, form the respective, that is what we call it as hydrides or binary compounds. What we call it as binary compound. For example, generally, see first we can tell that is nitrogen. Okay, they form a respective, that is hydrides, or react with metal, they form nitrogen. So react with calcium, form calcium nitride, Ca3n, and phosphorus, calcium nitride, Ca3p. Okay, then arsenic will form that is sodium arsenide. Okay, sodium arsenide. Okay, then even magnesium bismuthide, bismuth Mg3Bi. Like this, they form their binary compounds. I will tell you how to remember this. Calcium, you know, Ca2 plus, okay, nitride here, M3 minus. That's why I cross multiply calcium nitride. Ca2 plus phosphide B3 minus, minus 3 oxidation state, calcium phosphide. Okay, sodium arsenide Na plus, here As3 minus, but that is a negative oxidation state. Okay, therefore Na3 here, sodium arsenide. And magnesium bismuthide Mg2 plus, okay, then bismuth Bi3 plus, more stable, therefore Mg, what, it is Mg3Bi2. Like this they form binary compounds whenever they even react with the metal. So this is the reactivity with the metals. Okay, that's the reactivity with the hydrogen, reactivity with the oxygen, reactivity with the halogens, and reactivity with the metals forming binary compounds. And even I told you today, oxidation state also very, very important. Okay, now students, coming to lastly, anomalous properties. Anomalous properties of nitrogen. Means for theory purpose it will be asked for 3 marks. Important. And reason for anomalous properties separately for 2 marks. What are these properties? Very simple. See, now you are studying physical properties as well as chemical properties of all 15 group elements. Okay. What are the elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. See how nitrogen differs from rest of the elements. How nitrogen differs from rest of the elements, that is only called anomalous property. Last year also I told you 13 and 14 group elements. How boron differ from other elements and how carbon differ from other elements. Like this, how here nitrogen for 15 group, oxygen for 16 group, fluorine for 17 group. Okay, same trend also follows. First one, see. First important point is nitrogen. Okay, nitrogen exists as diatomic gas. Diatomic gas. Whereas other elements are solids. Okay, nitrogen exists as gas, whereas other elements are solids. Next, atomicity. Nitrogen is diatomic, whereas other elements are tetraatomic. Bodies. Remember. Okay, this is physical existence. Next, nitrogen is least reactive. Why? I told already, because of high bond energy. It It has capacity to form triple bond, multiple bond, and to break those 3 bonds we need 946 kilojoules of energy. Because of high bond energy, nitrogen is least reactive. Very important point to be noted for theory purpose for one class. Okay, nitrogen is least reactive, whereas other elements are more reactive. Why? Because they cannot form multiple bonds. They form only single bond. Okay. Then nitrogen can form P5 bonds or P5 interaction, P5 covalent bonding. Okay, whereas other elements form P5 interaction. Now, why sir nitrogen cannot form P5? Because d orbitals are absent in nitrogen, whereas d orbitals are present in other elements. Okay. And fifth point, nitrogen cannot form pentahalides, but others can form pentahalides. Why students? Here also same thing. Nitrogen d orbitals are absent, in other elements d orbitals are present. This is fifth. Then sixth, covalency of nitrogen. Nitrogen is 4. That means 2p orbitals are available for chemical bond formation. In 2s1, 2p, 2px, 2py, 2pz. 3 plus 1 total 4. But other elements can extend their covalency to 5 or 6. Why? Due to presence of d orbitals. Here d orbitals are absent in nitrogen. Okay, very important point to be noted. Right. That means, for example, here PF5, P1SF6. See, they can form 5 and 6. Like this. Nitrogen cannot form pentahalides, nitrogen cannot form P5 interaction, nitrogen cannot extend covalence more than 4. Why? Because of same reason. The orbitals are absent in nitrogen. These are the anomalous property. If they ask anomalous property, write any 4 anomalous property for 3 marks. Out of this 6, can write any 4. First, very important, see how it exists. The gas or solid, first point. Next, atomicity, diatomic, tetratomic. Third, reactivity. Third point, reactivity. Fourth point, okay, orbital overlap. Okay, fifth point regarding halides, pentahalide formation. And sixth point, you can remember regarding covalency. I'll repeat. What is the first one? That is state. Second one, atomicity. Like this, you can easily remember. Okay, third one, reactivity. Okay, fourth one regarding the overlapping. Okay, how the interaction is. And fifth point regarding formation of pentahalides. And sixth point lastly regarding covalency. So what is covalency, students? Covalency is nothing but the number of covalent bond formed by the element. It is not combining capacity. Combining capacity is valency, but this is covalency, number of orbitals which are involved in chemical bond formation. Remember. Okay? So that's about anomalous properties of nitrogen. See students, if they ask you for 3 marks, you should be able to tell these out of 6, minimum 4. Okay? Generally you will get confused, and this is a fixed question in the annual exam. examination. Okay. Now just I will write the reason for these anomalous properties. Now the question arises, why nitrogen differs from rest of the elements? What is the reason? Why it is showing these differences? The reason is very simple. Reason for anomalous property. Last one. Reason for anomalous property is simple. Reason for anomalous properties of nitrogen. Very important for 2 marks theory. Okay, the reason is nitrogen differs from rest of the element because of 4 reasons. First one, due to smaller atomic size. Simple, students, you write like this only. Smaller atomic size. Second, due to smaller atomic size, higher electronegativity. Okay. Then third, not only smaller atomic size, higher electronegativity, due to higher electronegativity, high ionization energy. Okay, and lastly, absence of d orbitals, very important. Absence of d orbitals. Because of these 4 reasons, nitrogen differs from rest of the elements. What are those elements? Phosphorus, arsenic, antimony and bismuth. Okay, this is for 2 marks. That means today what we have covered, students, in continuation, physical properties from electronegativity, right, then melting point and boiling point, then exhibiting allotropy, and even once again physical state I have repeated. Then in chemical property, first chemical property is what? Oxidation state. These 15 group elements, they exhibit, okay, variable values from -3 to +3 to +5, right? Okay, due to inert pair effect, +3 state becomes stable for arsenic, antimony, bismuth, and +5 becomes stable for nitrogen and phosphorus. Then take you to next, reactivity with the hydrogen, they form the respective metal hydrides. Reactivity with the oxygen form respective trioxide pentoxides. Reactivity with the halogens respective trihalides pentahalides, right? And reactivity with the metals, they form their binary compounds. And lastly, anomalous properties of nitrogen, how they differ from other elements in some properties, characteristics, and what is the reason for the anomalous property. Due to these 4 properties: smaller atomic size, higher electronegativity, high ionization energy, and absence of d orbitals. Right, students? So we'll stop today here. This is a completion of one part, that is physical and chemical properties of 15 group elements, even with the anomalous property. Today I have covered very important part of need purpose as well as for theory purpose. Out of this, you will have 1-2 marks question. Definitely, lastly, anomalous property. Reason Ityas, 2 marks. Properties Ityas for 3 marks. Okay? Right, we will stop today. In the tomorrow's class, I will tell you the compounds of this 15 group element. That is dinitrogen, next ammonia, and nitric acid. And this year, students, because of this, you know, the online classes COVID-19, they have deleted syllabus. They have deleted phosphorus, compounds of the phosphorus completely. So you are very lucky. Only compounds of nitrogen is remaining in the 15 group element. That is dinitrogen, ammonia, nitric acid. Their physical properties, chemical properties, we will discuss in the next class. Okay. So have a good day and enjoy the day. Bye, students.